Hi, and welcome to the last note-taking guide in our quadratic unit. Once again, we have a few short paragraphs at the top. Please read through them if you've not done so already. Pause the video and write your response. Simply summarize those three paragraphs in three short sentences and make sure your sentences are complete using correct spelling, grammar, and punctuation. When you're ready to begin, restart the video and we'll start our last note-taking guide on the quadratic formula. As our paragraphs above stated, sometimes we can't solve our quadratic functions by graphing or by factoring, or it's simply complicated to solve it by factoring. So sometimes when we're written in standard form, which is ax squared plus bx plus c equals 0, we can solve that function or find out where it crosses the x-axis by using the quadratic formula. Now, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Sounds complicated, but not really when we get going. First thing we need to do is make sure we write it in standard form. Write our function in standard form equal to 0. Now, nothing new here. We've done that before on several other occasions when we started to factor, etc. Next, we need to identify the values for a, b, and c. In other words, the coefficient of my squared term or quadratic term, the coefficient of my linear term, and then the constants. Then we're going to substitute those values into that quadratic formula. And follow the order of operations to simplify that expression. Simple enough. We identify A, B, and C, plug it into the quadratic formula. You don't need to memorize it because you're able to use that note-taking guide on any quiz or test we happen to have and simplify away. Let's take a look at an example. First example, use the quadratic formula to solve 3x squared minus 5x equals 2. Our first step is to get it in standard form or equal to 0. So I'm going to subtract 2 from both sides. So I have 3x squared minus 5x minus 2 equals 0. Next, we need to identify A, B, and C. A is the coefficient of my quadratic term, so A is a positive 3. B is the coefficient of my linear term, so that's negative 5. And C is my constant, so I have negative 2. So I've identified A, B, and C. Next, I need to substitute those values into my quadratic formula, and that is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So all that means is everywhere there's a, I'm going to put in 3, substitute 3. Everywhere I see a b, I'm going to substitute in that negative 5. And everywhere I see a c, I'm going to substitute negative 2. So this becomes x equals negative, and b is negative 5, so I substitute that in, plus or minus the square root of negative 5 squared minus 4 times the value of a, which is 3, times the value of c, which is negative 2, all over 2a. That's 2 times 3. Now, I start using my order of operations. That being the square root sign kind of operates like a parenthesis. So we're going to do everything under that square root sign first. This becomes x equals minus a negative 5 plus or minus square root of 5 squared. Negative 5 squared is a positive 25. So I can do that. Then I have negative 4 times a positive 3, negative 12, times a positive 2 makes that positive 24, all over 2 times 3 is 6. I'm going to continue down. I'm going to add a couple extra lines in here for you on the note-taking guide, noticing that I'm running a little long here. I'm going to keep going. So x equals minus minus 5 becomes positive 5, plus or minus square root of 25 plus 24 is 49 over 6. So this becomes x equals 5 plus or minus 7 over 6. Now that gives me two solutions. The first solution is x equals 5 plus 7 divided by 6. And my next solution is x equals 5 minus 7, all divided by 6. 5 plus 7 is 12 divided by 6, which will give me 2, is one solution. My next solution is x equals 5 minus 7, which is negative 2 divided by 6, which is negative 1/3. So the 2 points where my parabola is going to cross that x-axis is at a positive 2 and at negative 1/3. And I was able to accomplish that without factoring. Sometimes you might think factoring is the easiest way to go. Go ahead and do that if you think it's going to work. But sometimes we have quadratic equations that don't have a factorable equation. Please pause the video now and try example 2 on your own. Restart and when you're ready to check your solution. Let's see how we did. First thing is to write it in standard form, get it equal to 0. So I'm going to add a 6x and a positive 7 to both sides. And that will give me 2x squared plus 6x plus 7 equals 0. Next, I need to identify A, B, and C. And I think I'm going to use different colors to show you where they go into the formula. So A is the coefficient of my squared term. B is the coefficient of my linear term. And C is my constant. Using my quadratic formula and substituting in, I will have x equals, I'm going to put my line out, negative b plus or minus the square root of b squared, which is 6 squared, minus 4 times a, then times c, all over 2 times a. Oops, color didn't change. Let me erase that. Hang on just a second. Times 2a. There we go. And a is a positive 2. Notice that 6 went in everywhere there was a b, 7 went in where I had a c, and 2 was substituted in where we had a. Using my order of operations, x equals negative 6 plus or minus 6 squared is 36. Then I have negative 4 times 2, which is negative 8, times 7 is negative 56, all over 2 times 2, which is 4. Continuing on, x equals negative 6 plus or minus square root of negative 20, all divided by 4. Now I need to simplify that square root of negative 20. And that's going to give me what kind of number? Imaginary. That's right. So this becomes x equals negative 6 plus or minus the square root of negative 20. Let me just come over on the side so you can see my thought process. The square root of negative 20 is the square root of 4 times the square root of 5 times the square root of negative 1. If I multiply those together, I'll get negative 20. So that's plus or minus the square root of negative 4 is 2. Square root of negative 1 is I. And then the square root of 5 I'm going to leave. So I'm going to have 2I square root 5 all divided by 4. Now, what do you notice between my terms of negative 6, 2I square root of 5, and my denominator of 4? Well, they're all even. So I can factor out a positive 2 here. So I'm going to have x equals 2 times negative 3 plus I square root 5 all divided by 4. And then I can cancel out 1, 2 in my numerator and denominator. So the solution is x equals negative 3I. Whoops, sorry about that, another mistake. So let's try this again. X equals negative 3 plus or minus I square root of 5, and that's all divided by 2. So let me write it over here where I have more room. X equals negative 3 plus or minus I square root 5 all over 2. So we don't think that the I square root 5 is the only thing divided by 2. So graphing here would not have given me a very accurate solution. And factoring, I think, probably would be difficult. I'd need to find factors of 14 that added to a positive 6, and I don't think I have those. So I would have to use the quadratic formula in this case. I'd like you to do the next example on your own at home and bring it with you when we're together next time in class, and we'll go over it then. Please move on to our next video, which is evaluating the discriminant and what that tells us about my solution set.